today's lesson we're going to have a look at resistance in an electrical circuit. And as the name suggests, resistance is a force that reduces or stops the flow of electricity in a circuit. Electricity is the flow of electrons around the circuit, and a higher resistance will decrease the flow of electrons, and lower resistance will allow more electrons to flow. Let's watch this video to introduce the idea of resistance.
Resistance. In this case, the resistance of a dog to giving back a toy. In the case of electricity, though, resistance is a measure of the difficulty of passing an electric current through a conductor. The higher the resistance, the harder it is for the current to flow. When a current flows from A to B, there is resistance. Resistance in a wire, for instance, increases as the wire gets longer or as it gets thinner. Electrons bump into positive metal ions as they travel through the wire, and the longer the wire, the more ions there are to bump into, so the greater the resistance. A thin wire has a smaller cross-sectional area, which means there are fewer electrons to carry the current. This increases the resistance, a bit like a road with one lane compared to a dual carriageway.
So hopefully you found that video helpful, but there's a few key things to keep in mind with today's lesson. First of all, current that we've been talking about, that we have been measuring using an ammeter. Electric current is the flow of electrons in a circuit. In this little animation, the electrons are represented by the negative particles, those little yellow circles with the minus signs on them. Voltage, as you may have heard about before, is like the pushing power of a circuit, the amount that the electrons are pushed around by the circuit. So current is the flow of electrons in a circuit, and resistance is essentially the opposite to that. It's the opposition to current. So a bit like if somebody was trying to move forward but you were pushing against them to stop them from moving forward. So the resistance is like that blue hand pushing against the flow of electrons. So that's something to keep in mind with today's lesson. So now what you need to do is to use the following videos put together by Miss Wallace to take you through pages 8 and 9 of your booklet. Try and fill in the gaps as you go. One thing to note is that when she sets up this first experiment and recording the reading with the thickest wire, you may disagree with the first current reading, and if you want to, you can write down the reading that you actually see on the ammeter instead of the one that she quotes, but either will be fine. You will be able to come to the same conclusion. So use the videos to fill in the gaps as you go for page 8 and 9. And remember, you can pause and replay the video if you miss anything at any stage and need to go over anything. But by the end of these videos, you should have completed pages 8 and 9.
Hi girls, we're going to look at page 8 in your notes to do with resistance. So we've set up the following circuit, and in it we've got two batteries. We've got our ammeter, just here, and then we've got our crocodile clips that are used to connect a piece of wire. Now, our piece of wire is going to be 1 meter long, so this has been measured out as 1 meter in length, and then to save it being so long whenever we're using it on the table, we've just wrapped it around a piece of cardboard. So that's 1 meter length of wire. Now this wire is the thickest one, and we've also got medium thickness. You can see that it's slightly thinner, and the last one we've got is the thinnest. You can see that that wire is thinner, but they're all 1 meter in length. So we're going to start with the thickest wire in our circuit, and what we want to do here is we want to measure how much current is flowing around the circuit. So I'm using my crocodile clips just to clip that into place, and then we're going to take an ammeter reading. So you can see that the needle on the ammeter has deflected from the 0 position. Now we need to be careful as to what scale we're reading off. We're connected in here to the 5 amp scale, so we're reading off the bottom scale, which is 0 to 5 amps. And if you want to pause the video, you could have a closer look at what the needle is sitting at. Let me have a little look. So I'm going to take that as being 1.6 amps. So for the thick wire, you can fill in the value there of 1.6 amps. Next wire we're going to put in is the medium thickness. So the circuit's going to be kept the same. 2 batteries in series with an ammeter. And we pop in our 1 meter length of medium thickness wire. Hopefully you can see most of that, girls. So again, our ammeter needle has deflected. Now it's sitting between the 0 and the 1. Remember, we're still in the scale, the 5 amp scale, the bottom scale. So it's sitting between 0 and 1. So that tells us that the reading is less than 1. So what we can do here is move over to the smaller scale, the 1 amp scale. There we have it. So we're now reading off the 1 amp scale, 0 to 1 amp, that is the top scale. So again, if you want to pause that, girls, and have a look and see what you think the reading is. So I think the reading is just past 0.5. I would say that's almost, yeah, we're going to go with 0.52. 0.52 amps. And you can record that into your notes just here, girls, for the medium wire. And the third one, the thinnest wire. So let's connect it in. Again, still just 1 meter long. Trying to make sure that my crocodile clips don't touch any other part. Oh, where's the other end of this one going? It's around here somewhere. There we go. It's connected. I've got my reading on my ammeter. There we have it. And again, you can pause the video and see what you think the reading is. Remember to read off the correct scale. And I'm looking at that saying it's, yes, I'm going to go with the 0.4. 0.4 amps, reading off the top scale. So again, you've got your value then to fill in here, girls. So in conclusion to this, the electric current is the smallest with, well, that was with the last wire. It was just 0.4. So that's with the thinnest wire you'll be filling in there. Hi girls, at the bottom of page 8, you've got another circuit diagram and it's got the heading variable resistance. So you've been asked to set up this circuit. I've got it here for you. The 2 batteries, just here, and connecting round to the ammeter, which is just here. And then we've got this part of the circuit where we can insert a piece of wire. So just like we were doing at the top of page 8, except we're going to use slightly different pieces of wire. So we've got one piece of wire that is 1 meter in length, a second piece of wire that is 50 centimeters long, and third piece of wire that is just 25 centimeters long. And just like before, girls, instead of having a big long piece all laid out, the piece has just been wrapped around some cardboard to make it more manageable. So we'll start with the 100 centimeter. I'm going to put it into our circuit. Whoops, using the crocodile clips, and we're going to be reading the value for the current from the ammeter. So if I bring that up, you can see the needle has deflected past the 0. I've got it connected into here to the 5 amp scale, the bottom scale, and it hasn't gone past 1, so we know that we can move it on to the 1 amp scale then. There we have it. And if you want to pause the video, girls, you can try reading what that value is. So reading off the top scale, it's just gone past the 0.5 and I'm reading that as 0.52. So for the first value, the 100 centimeter length of wire, the current is 0.52. Let's try now the second piece of wire. But you have to be careful in these experiments because the wires can get hot. So second piece of wire is 50 centimeters long. It's a bit shorter, half the length of the first one. And let me just fix that around the back and connect it in using the crocodile clips again. There we go. And you can see, like before, the needle has deflected off the 0 position. I moved it back on to the 5 amp scale. It has just gone past the 1 on the 5 amp scale, so I'm not going to move it on to the 1 amp scale because it would go past the end of the 1 and could possibly damage the ammeter itself. So if you want to pause it again, try to read that value. I'm reading it as 1 point. Hi girls, just following on that video, last video cut out a little bit there, so I'm just picking up where we left off. So the reading that I got on the ammeter for the 50 centimeter piece of wire was 1.2 amps. So the last piece of wire that we have here is 25 centimeter length. So let's connect it in. This is our shortest piece of wire. I wonder, can you predict what the current is going to do here? So I've got that connected in. Let me bring the ammeter up to you. And again, I'm still connecting here on the 5 amp scale, so that's the bottom scale. Pause the video and see what you think the value is, the reading. So the value that I'm getting, it's almost at 1.5, but not quite. I'm going to go with 1.4 amps for that one. So those are our values, girls. Our 100 centimeter length had the lowest current, so the longest piece of wire allowed the least current to flow, and the shortest piece of wire allowed the greatest amount of current to flow. So in your conclusion at the top of page 9, the current is the smallest with the longest wire, and it follows that the longer the wire, the greater its resistance. So the longer the wire, our 100 centimeter piece of wire, didn't allow very much current to flow along it, so it was offering a lot of resistance, and so we say that it has the greatest resistance out of these 3 pieces of wire. Hi girls, at the bottom of page 9 there's a little section that's got the heading "A dimmer circuit." Now it says set up the following circuit with the rheostat dial turned fully anti-clockwise. Well, first of all, this is what a rheostat dial looks like. So it's a little component we can put into a circuit just like all the other components, got connections either side, and this turns, this little dial, and that allows us to vary how much resistance is in the circuit. So let's see it working. I've got the circuit set up here, so it's got the 2 batteries at the top. At the left hand side it's got my bulb. In the centre there it's got our variable resistor, or rheostat it's called as well, and on the right hand side then just there is our ammeter. So this is a simple series circuit, there's just one loop, so these are all just connected one after each other. So the instructions were to have the dial fully anti-clockwise to start with, so you can see my little marker is sort of pointing southwest, that's it, turned as much anti-clockwise as it'll go, and we're asked to gradually turn the dial clockwise and note what happens. So I'm going to do that. And we have to note what happens to the lamp's brightness, the lamp's temperature and the current. So we'll focus on the first one, the lamp's brightness. So you can keep an eye on the lamp as I turn the dial. Just pull this out a little bit. So as I turn the dial clockwise, you should hopefully see there, you can see that the lamp has increased in brightness. I'll turn it back again. Okay, so that was my starting position. Turning it clockwise, the lamp is now much brighter. So we can vary the brightness of the lamp there just by turning the dial. So in your notes, the lamp's brightness increases. Secondly, the lamp's temperature. Well, if the brightness of the lamp is increasing, then its temperature is also increasing. As it glows more brightly, it's going to be at a higher temperature, so that is also increases. And finally, the current. Let me go back to my starting position. So I need to keep an eye on the ammeter to see what's happening to the current. So as I turn the dial, watch the needle. The needle is deflecting further around to the right. So that means the current is increasing. We're allowing more current to flow around the circuit. So here, the current increases.
So what next? Well, now that you have completed those videos, I would like you to check your answers or fill in any missing gaps using the completed notes, which you can find in today's instruction documents. If you have time, then you can start to complete the homework task on page 10 or 11, but you will also have your single period at the end of the week to complete this task as well. So you don't have to finish it today, but if you would like to get a head start on it or complete it today, then you can do that now. Then what you should do is to check the assignments area of our Teams page and submit any other work that you're missing. Let me know if you have any questions.